Here we will talk about the light interference, the third property of the light. So we will have to assume that you have two different sources in your room for light. A white lamp, which is nine lamp, and another red lamp. Both together are powered on at the same time. So you have to know that the white light and the red light will interfere together to propagate through whole air medium in the room. So you have to know the mechanism of interference of two sources of light, but in your curriculum, the curriculum are talking about the two identical sources of light. And to be sure, the curriculum to be sure that they are identical, he came with one light source only, passes its light wave, through a screen which is called first screen or monochromatic screen, which means monochromatic, a constant wavelength. The propagation will have a constant wavelength. So the first screen is functioned by a monochromatic screen, which means a constant wavelength. So the propagation of the light will have a constant wavelength. Then the wave will pass by the second screen, which is called a double slit screen. Double slit screen is the whole name of the experiment of Uncle Young, the scientist Young for sure. Scientist Young will make two coherent waves or two identical waves. Here from this space and from this space or from this slit or holes, slit 1 and slit 2, two coherent identical waves will be produced. The red wave and the black wave will interfere together at this point. At this point, you have to know that the crest may meet the crest, or the trough may meet the trough. You have to know that the interference will be resulted on a third screen. The interference will be resulted on a third screen. The third screen will have a black spots and white spots, a black spots and white spots, a black spot and white spot. They are called frames. All of this black and yellow, they are called frames. So, bright frame and dark frame, bright frame and dark frame. The distance between a center of bright frame to another bright frame is called delta y. The distance between the center of bright frame to the next bright frame is called delta y. Also, the distance between center of dark frame and another center of the successive dark frame is also called delta y. The distance between the two slits is called d. The distance between the second screen and the third screen is called r. So you have to know that delta y will be equated with the product of the wave length, which is constant, the wave length, by the r divided by the distance. Delta y will equate with the product of the wave length of the source by r, which is the distance between the second screen and the third screen, divided by d. So from this rule, I can get the value of the wavelength, which is by cross multiplication. Wavelength is delta y by d divided by r. So you have to know that the interference experiment is made or functioned by analyze of the interference of the light, to analyze the interference, to make sure that the interference will take place to give two types of the interference, constructive interference and destructive interference. Second way to know the wavelengths is by making interference experiment. You have to know that the delta y as observed and the distance between the third and second screen and the distance between the two slits can be used to detect the value of the wavelength. So you have to know that the interference takes place at that formula. So if we are talking about the types of the interference will be in two types. The constructive interference, which indicate that the crest meet the crest when the two waves of light meet together. The crest will meet the crest, the two crests will meet, or the trough will meet the trough, the two troughs will meet. So it's a constructive interference. And white spot or bright fringe appear on third screen. So when a bright fringe appear on the third screen, it's a result of constructive interference. And when destructive interference takes place, it takes place by a crest meeting the trough or vice versa. When it takes place, a black spot or a dark fringe will appear on the third screen. So you have two kinds of interference: constructive interference, which gives a bright fringe, and destructive interference, which gives a dark fringe. You have to know that there is a phase difference between the two fringes. The phase difference is 0, 1, or 2, or 3, submitted by the wavelengths. And the destructive is half, 3 over 2, 5 over 2, 7 over 2, submitted by the wavelengths. You have another way of the interference, which is Ayres disk. Ayres disk is about a light source passing its wave to fall on a screen. This screen, the wave of the interference inside the same source, will get a white spots and black spots. Will get a white spots with the black spots. The white spots with the black spots is due to the two kinds of the interference, the constructive interference and destructive interference. Second session, we will introduce the diffraction between the light and make some examples about what we have learned in reflection and refraction and interference. Thank you.